This is my brand new $5,000 custom loop gaming PC build, and I think we can probably all agree that it looks absolutely stunning. But when I say that everything that could have possibly gone wrong with this build went wrong, I'm not exaggerating. And in this video, I'm going to talk you through the story of the most painful gaming PC I've ever built, what went wrong, the parts that are in it, and see if it's actually all worth it with those all-important temperature figures a little bit later on. Let's do this. The Cooler Master GM2711S is a QHD 180Hz gaming monitor with Cooler Master's unique advanced reflectionless technology. The unique film reduces glare from ambient light, all while increasing screen visibility and reducing eye fatigue. The 2560 by 1440 resolution looks sharp too, while the 27-inch form factor is a real sweet spot for 16 by 9 gaming monitors. A 0.5 millisecond response time and ultra-speed IPS panel make this display competitive too. Learn more at the first links in the description below. The story of this build actually traces back as far as March, when Corsair announced this, their XH405i RGB. It's basically a hardline water cooling kit that has everything you need to get started. 3 fans, a pump res combo, CPU block, a radiator, some tubing, and an iCUE Link hub. That's this thing right here that's going to control all of the RGB effects within the system and provide power to all of the fans and water cooling devices. Now this just so happened to coincide with the release of Corsair 6500, and it got me thinking, why not combine the two together, and heck, why not use it as an opportunity to upgrade my personal rig? I've been rocking Intel at home for a while and wanted to switch over to the 7800X3D and give Ryzen a go. This then seemed like the perfect opportunity. I went ahead and gathered up a load of other great parts to make the build possible, from MSI Suprim RTX 4080 to their X670E Ace motherboard for loads of features and connectivity, as well as 32 gigs of Corsair memory so I could sync the RGB up with the rest of the build, and a Gen 5 PCIe drive that provides frankly ridiculous speeds that are very overkill for the use case of this build. But I build PCs for a living, and my personal rig should be a real showcase of my abilities and what I could do. At least that's how I've justified this great expenditure to myself. And it would be safe to say the build started off pretty well. I obviously went ahead and popped the Waterblock onto the Suprim cooler first of all. Corsair do a universal iCUE Link compatible design, but I like this as it was bespoke for the card and I think looked far more premium. The Waterblock was really easy to install compared to some of the other soft and hardline systems I've built previously, and the 6500's clever design made actually getting all the radiators to fit and getting all the fans in nice and easy. I decided to mount the pump res combo to the fans on the side, and these QX fans, which are Corsair's very expensive but stunning fans, made the build a dream. The reason is they look fantastic from both sides, meaning that top, bottom, side, front, rear, you're never going to have any aesthetic issues with the RGB being the wrong way. So with all of that, the build was assembled, and there was a few areas I felt like I perhaps made the wrong decision. These are Corsair's new cheaper RX, but still quite pricey iCUE Link fans, and I think I should have just gone full QX for the whole build. It would have looked more uniform and frankly far more premium. I have got a 140 I can use to swap the one at the rear out, but obviously these ones aren't going to be removed without draining the whole loop, which I do not want to do. I also picked up an extra radiator, which mounted in no problem. With this being a loop for CPU and GPU, I figured 2 rads was certainly better than 1, and this build rocks a grand total of 13 fans to try and keep things cool. Airflow for me was important, and although the front is glass, which is going to show off the water cooling, I still figured there was plenty of room for ventilation and plenty of ability to keep temperatures down. So far, so good then, and I began bending all the tubes. Now, this is where the first signs of things going a bit wrong kind of happened. I've built a couple of hardline loops in the past, and I'm not going to profess to be any great water cooling expert. However, I like to think that I know enough to tell you guys what I think is good and what isn't good, but I still do have plenty to learn. Now, for the life of me, I couldn't seem to get the tubes in this build to bend without kinking and bubbling on the corners. No matter how many tubes I tried to bend, no matter how hot I had the heat gun, I could not get it to work. I tried putting it on medium power and holding it there longer, or putting it on high power and having the tube basically disintegrate in my hands, and whatever I did, I couldn't get it to work. As you can see from all the B-roll, I properly inserted the rubber inner tube before bending this plastic tube in. The reason for that is to basically hold the form of the tube inside and stop the tube collapsing on itself when you bend it. That's going to ensure that your bends remain nice and rigid and that the internal diameter is still big enough for liquid to flow without any issues. So with all of those challenges occurring, I thought, you know what, sod this, I'm going to take a break, come back to it later, I must be doing something wrong, and decided instead to place the only non-bent tube in the system first of all. And again, I encountered another problem. This kit really nicely includes a vise with a hacksaw, so you can easily actually trim the tubing to length. The only problem with the vise is that, well, it's just a bit rubbish. When you tighten it too much, the tubing begins to crack. And when you actually put the saw down the edge of the vise, unless you're very, very straight naturally, you can actually end up either sawing the tube at an angle or sawing through the vise in its entirety. That's right, I actually ended up sawing the end off of the vise on both sides. With issues cutting the tube, I then decided to ditch the vise and rather than sawing by hand, use the handy tube cutting tool I've employed for my last couple of hardline builds. In my last systems, I had no problems with tubes cracking or breaking under the pressure of this tool, but simply put, the tubing in this Corsair kit couldn't handle it. Instant cracking, instant damage to the tubes, it just was not going to work. Cutting the tubing then by hand seemed to be the only palatable option, and that is what I ended up resorting to in the end without too many concerns. With the tubes cut to the right length, I then reached out to my representative at Corsair and said, look, I'm having problems bending the tube, what am I doing wrong? I was advised that use of the tool in the box, which actually helps you mold to shape more easily, is basically mandatory if you want to actually bend the tubes without the bubbling and the kinking. The reason for this actually comes down to the type and material of tubing used. Corsair use PMAA in this and their other kits, which is harder to work with in the first place, but meant to be less reactive to coolant and have better durability in your build over the longer term. I'm used to using PETG, which is far more workable, malleable, and I'd argue much more easy for beginners when assembling the system, but does have documented drawbacks over long-term use in a system. Not that I can personally say I've had any with any of the PETG builds I've built previously that are still working fine to this day. To be clear, even with the tool, I did have problems, and I also found that when you've got multiple bends like this one here in a single run, using this tool can be really difficult. Getting the tube nice and hot, getting your bend point ready to go, and then having to put the tube inside of the mold is just a little bit cack-handed, and I find makes the whole thing pretty difficult. Either way, maybe I was being dramatic. The tubing had got the better of me, not been used to maybe this particular model or diameter of tube before, got the runs, happy days, all sorted. Or at least I thought. Now the next step was to wire up all of the water cooling gear, all of the fans to this. This is the iCUE Link control hub. Now this is powered by a 6-pin GPU power connector, and the hub can handle up to 14 devices. That's 7 per channel. One channel on one side, one channel on the other. You plug from one device into the next device, that goes to the next, and they all communicate like a network. The idea being, rather than a daisy chain where the signals pass through, there's actually a level of communication where you plug one device into the hub, the device goes to the hub, hello, I'm a fan with 3 rings and 142 LEDs, and the hub goes, great. And then the other fan goes, hello, I'm a cheap fan with only 8 LEDs, and the hub goes, great, and it knows what to do. That's the idea anyway. Now I did have to use an iCUE Link splitter, which makes things more complicated. The reason for that being that the CPU block and the pump res combo only have one iCUE Link port on. The fans, for example, have one port on each side, which allows you to more easily daisy chain. And the GPU, which isn't iCUE Link compatible officially, had a non-iCUE Link to iCUE Link adapter. So again, only one port there, meaning daisy chaining this just was not really possible. I'd done the calculations and the whole build should have been possible with just 2 hubs. That's because each hub can handle up to 14 devices. I've got 13 fans, a pump res combo, 14, CPU block, 15, and a GPU block, 16. 16 total devices. And for love nor money, we couldn't get it to work. From overvoltage protection errors to fans dimming because of too much power consumption through the hub, or at least supposedly, we were just having no luck. In fact, even worse than that, when we booted this system up and got into Corsair iCUE, the only thing we were met with was red flashing and full fan speed throughout the whole build. As you can see from this video where I am, at this point, quite frustrated. Brightness reduced. The maximum brightness reduced due to the iCUE Link system hub power limitation. So that's a bit rubbish, but we haven't got any massive errors like we had last time. Oh no. No! No! Not again! Please! Oh! And it was these issues that continued to plague us for days and days and days. We updated the firmware for all of the iCUE Link hubs, waited for new releases of iCUE, and communicated back and forth with, to their credit, our fantastic representative at Corsair. Now, after some communication back and forth, we made a little bit of progress, and the build started to come together. More and more devices started to work, kick into action. iCUE started to play ball. I thought maybe we're in luck. Oh no, pump error. Fatal pump error. Now, Corsair iCUE then seemingly telling us there's a problem, and rather helpfully, unlike lots of other software suites to Corsair's credit, telling us where it thinks the problem is. The pump. I thought, fantastic. Well, not fantastic, because nobody wants a broken pump, but the offending pump was then removed and a new pump res combo was supplied by Corsair for the purposes of the system. So we went through the process of draining the loop, something which would have been easier if I'd put an inbuilt drain port on, but it didn't, so it was a little bit complicated. Anyway, got the loop drained, took most of my tubing out, and replaced the pump with a new one. We booted into iCUE with nerves and great anticipation, and guess what happened? Pump failure! Oh yes. Could I really be statistically the unluckiest man alive and have 2 broken pumps in a row, bearing in mind that both were supplied directly from Corsair and hadn't come from a retailer or any sort of warehouse batch? That seemed to me to be a bit unlikely. So having gone through the effort of filling the loop for the second time, we booted into iCUE and were determined to find a solution. And a solution we found. What we did was we isolated every individual device, all 16 of them in this system, to determine at what point the error began to occur. And we very quickly figured out that when we put the CPU block in, that's when the pump error flashed. Now, what was really frustrating about this is that those of you who know about water cooling will know this CPU block doesn't actually do anything. Now, when I say that, of course it does. It has fins, the water flows through it, it transfers the heat from the processor and keeps it cool. But the actual connectivity to the system is to power the RGB lights and literally nothing else. There's no pump module, there's nothing powered. This does not need to be plugged in order for the CPU to stay cool, but it's of course providing us loads of data and lovely RGB. Unplugging this seemed to revert the system back to normal, and while we were still seeing sporadic issues in iCUE whereby fan brightnesses were dimming because of potential overvoltage protections, an extra couple of iCUE link hubs resolved that. In fact, this build is currently working with a grand total of 4, which is double the amount Corsair say it should really need. I'm not sure whether fans like these QXs simply consume a lot more power than perhaps the 14 devices Corsair think you might plug in at once. I honestly am still not particularly sure. So with that in mind, we emptied the loop again and removed all of the tubes again. Fun fact, I think this video has a total of about 11 hours of footage. We spent 11 hours filming this build. Yes, this was a deep dish. So the CPU block got removed, a new CPU block went in literally last week, and voila. Now we're going to look at performance in a minute. I'm going to stress test this thing and see how the temperatures actually hold up. But I thought it was only right to properly talk about the issues we faced here. Now, I think Corsair iCUE is still, by a mile, the best piece of RGB and overall system control software that we have when you look at the other options within the cooling case and fan space. However, it's very clear to me that there are some fundamental software issues, and a quick Google on the internet whenever we encountered a problem resulted in an innumerable number of Reddit threads, forum posts, whether that be on Corsair's own forum or others, of issues with Corsair iCUE. Now, to their credit, the new version of iCUE is far better, and when we run the wizards whereby it auto detects what's plugged in, it seems to be doing a much better job. But the problem in iCUE we had with the CPU block is that we couldn't ignore the error. We couldn't say to iCUE, yep, we know the CPU block is very broken, let's forget about that. Instead, it goes into some sort of protection mode where everything else flashes red as if to say, look, there's a major problem. Now that'd be great if actually the pump had failed, because if the pump's failed, you're not going to be pumping the liquid round and you're going to be seeing huge temperatures, and that's an issue you obviously need to address. So they've put a protection in there to try and protect you if any of their stuff happens to go wrong or you've not wired something incorrectly. But whenever the software sees a problem, it just seems so hard to navigate, particularly impossible to override, and so difficult to actually modify and adjust any of the settings. It just freaks out and goes, there's an emergency, we need to solve it. And the fact that it's taken a couple of months for iCUE to improve to the point where we now think it's actually pretty usable again, and it's taken us the best part of 8 weeks to actually get this build finished, assembled, and tested, is an awfully long time. And it's great because we have that direct line of contact with Corsair, and to their credit, they've been really communicative in trying to get this build sorted and get to the bottom of the problem. In fact, they've actually shipped the other CPU block off to their iCUE Link Center in Europe, where they're going to test and see if it's a defective unit, whether this problem potentially affects any other units out there, and how the problem can hopefully, I guess, be avoided in the future. But you guys watching this video don't have that direct link, and while I'm sure Corsair support would have helped, it was far from an ideal situation. So with that, was it actually worth it? Now, I went in and ran FirmArc and CPU-Z on 100% load for both CPU and the GPU at the same time. This is a workload you're never really going to see in real life, maybe video editing, certainly not gaming, and the temperatures were superb. I'd even go as far to say that I'm not sure the second rad was actually required, but it's certainly something I was pleased that I put in, as the extra cooling capacity it's given allows, of course, for the fan RPMs to be tuned down and the system to remain much more silent under operation. In gaming scenarios, those temperatures are even lower, and this system is an absolute dream to use day to day. The RGB customization is also superb in iCUE, and while I'd like to see more of their iCUE Link presets that have a greater RGB coverage, what I mean by that is lots of the Link presets are kind of individual LEDs on bits and bobs here and there. I have to say, all in all, it looks superb. And that iCUE Link connectivity standard, when it works, is superb, but it's expensive. And the problems we faced during the build are ones I really hope you guys don't have to face if you're dropping this much money on water cooling gear, because believe me, this build wasn't cheap. So with that, I'm going to leave you guys on a stunning montage of how incredible this system looks. Thanks for watching, and as always, we'll see you in the next one.